Hello everyone, I welcome you all to now the third concept video of the geometry. So in this particular video we shall be looking at few more questions from the triangles area first, right, and as I said in the previous video we shall be covering other areas of geometry, polygons, circles also in our subsequent videos, right. So let us get started with the video. So today's video is mostly about question discussion, right. There is almost no theory as such. Theory, whatever it is, it would be pertaining to the question only, right. So I will just show you the first question for today. You have it in your screens right now. You can just pause the screen at this moment and try out this question yourself, and afterwards, like after trying it out for like around 3-4 minutes, let's say, yeah, if you get the answer very well, you have the option choices here. You can try to match with one of them. Anyways, resume watching the video and try to follow what we are discussing here. I, however, will be discussing here in the class, continuing with the discussion. Let us look at the question. It says in triangle ABC, D is a point on AC and divides AC in the ratio 1:2. D is a point on AC and divides AC in the ratio 1:2 means D would be somewhere here. This is one part, this is two parts. E is a point on AB such that CE, let us say E is here, E is a point on AB, E will be here, such that CE, so I have to connect C with E, divides BD, I have to connect B with D also. So CE divides BD in the ratio 2:1. So let us assume CE is cutting BD at point F. Just a minute. So let us say this is F here at this point. So also the ratio is given BD in the ratio 2:1. So that means this FB part will be 2, this FD will be 1 part. Find AB is to EB. We have to find AB is to EB. Okay, there could be many ways of solving this. So one of the ways in which we can look at this problem is by using areas of triangles, right. So before I continue discussing this question, there is a small point I would like to share. If two triangles have the same height, then the ratio of the areas will be equal to ratio of their bases. Two triangles having same height. So we know that area of triangle is half base into height. If two triangles have, let us say, bases as B1 and height as H, second triangle has base as B2, height is same H. So when you find the ratio, H will cancel out, half will cancel out, you will be left with only B1 by B2. So that means ratio of the areas is nothing but ratio of the bases. So means if you take bases in the ratio 1:1, area will also be 1:1. If you take base in the ratio 3:5, area will also be 3:5, alright. So this is a point I would like you to understand. So the point is, I will just write it down and clean it. In two triangles with equal heights, ratio of areas will be equal to ratio of the bases, okay, ratio of bases. So let me just clean this. Now after we understand this bit, can we say the following? Please notice, if you look at the triangles CDF, I will just say out the triangles, you please note it down and please observe them, those set of triangles actually, CDF and CFB. So basically these two triangles. Now can I say these two triangles have the same height? Why? Because how do we find the height? From C we drop a perpendicular. So whatever perpendicular we will drop for this triangle, same will be the perpendicular for the other triangle, right? Both will have the same height, we can notice that. So if they have the same height, the ratio of areas is equal to ratio of the bases. What is the ratio of the bases right now? 1:2. So that means if the area here of this smaller triangle is k square units, this will be twice of that, 2k. It's all right. Next, let's do one construction here. So if I connect A with F, now look at the triangles FDA, this triangle, and FDC. FDA and FDC, they also have the same height. So if they have the same height, ratio of area should be equal to ratio of the bases. What is ratio of the bases? 1:2. Area should also be 1:2, meaning if this is K, this area, this one, FAD triangle will have K by 2 square units. This will be K by 2 square units. And by the way, I just crossed over this 1. So this part is 1, FD, FB is 2. Note that also, alright. FD is 1 and FB is 2. Next point, please note, consider the set of triangles AFD, AFD and AFB. AFD and AFB, can I say once again this set of triangles also have the same height? Height will be nothing but the perpendicular drop from A. It will be same for both the triangles. So thus for this triangle also ratio of bases is equal to ratio of areas. What is ratio of bases? 1:2. Ratio of areas will also be 1:2, meaning this entire triangle, area of triangle, I will write it here, AFB will be equal to twice of this. So it is also going to be K. So this triangle will also be K. Okay. Now out here, this entire group we know as K. Triangle AFB we know as K. We don't know how much is AEB or we don't know how much is EFB. So let's assume this EFB triangle is some variable x square units. That means this will be how much? K minus x. Correct? X and K minus x. We have to somehow try to find the value of x there, right? Let's see how we can do it. So what I'll do is, can I say, consider the following pair of triangles now. Triangle FEA and FEB. FEA, FEB. So can I say area of triangle FEA by area of triangle FEB will be nothing but, since they have the same heights, will be nothing but ratio of the bases, which is nothing but AE by EB. This means what? FEA is how much? FEA is K minus x and FEB is x. This is going to be AE by EB. We may write this. Right. Next, consider the following pair of triangles now. Triangle CEA and CEB. CEA and CEB, can I say area of triangle CEA by area of triangle CEB will be equal to, CEA is how much? They have the same height, so it will be equal to AE by EB again. So can I say this is CEA is K 2K 5 by 2K minus x. CEB is how much? 2K plus x. AE by EB. This is also AE by EB. This expression is also AE by EB. We can equate the two. So when you equate the two, let's see what do we get. So when you equate these two, I'll write it here. So that will give me K minus x upon x will be equal to 5 by 2K minus x upon 2K plus x. Cross multiply. So when you do the cross multiplication, we'll get 2K into K, 2K square plus Kx minus 2Kx. So minus Kx minus x square. This will be 5 by 2 into Kx minus x square. When you cross multiply this with this, minus x square cancels out. So here you will get minus Kx goes on this side, so 2K square will be equal to 7 by 2 Kx. 1K can be cancelled out because it cannot be 0, because K equal to 0 would mean what? So K equal to 0 would mean each of these areas are 0 and 0, which is not possible, of course, which is not practically possible. So K will avoid it to be, will not take it as 0. So thus can I say the value of x will be 4K by 7. So we get the value of x as 4K by 7. So we know this x now in terms of K. So can I say now AE by EB, I'm continuing here, AE by EB will be equal to what? K minus x. K minus x, x is 4k by 7. So k minus 4k by 7 is 3k by 7 by x is 4k by 7. So this k by 7 cancels out, I will be left with 3:4. So that means AE is to EB is 3:4. So if this is 3:4, what is he asking us? He is asking us AB. AB will be how much? 7 parts. EB is how much? EB is 4 parts. So my answer should be 7:4. So option choice D is going to be our correct answer. So this question is entirely based on the simple concept that if two triangles have same heights, the ratio of areas will be equal to ratio of bases. Right? I hope you are clear with this. Please copy this. I'll just clean this. Moving on. One more question. You can just try to solve this. Pause the video for a while. Right? Try out this question. So in this series of videos, so we are coming across a question that deals with triangle as well as a quadrilateral, square in this case. In the basics we know area of square is what and all, I am sure we all know that. Let us look at this question. A square of the longest possible side is drawn inside the triangle ABC with one side of the square lying on BC. BC length is also given to us. If AB is equal to 13, BC is equal to 21 and AC is equal to 20. So I will just draw the diagram once. ABC is like this. So BC is 21. AC is 20. This is 13. Then find the side of the square. So side of the square is what? Blank by 11. So I have to fill this blank, the numerator part here. So we can do the following. Here, the very first thing is it's a scalene triangle. So let's try to find its area. So when we try to find this area, its area, we can use the Heron's formula for this. Area of this triangle is square root of. Semi-perimeter is how much? Semi-perimeter will be sum of the sides 33, 54 by 2, 27. So S is 27, so S into S minus A, 27 minus 13 is 14, S minus B, S minus C, 6. Now simplify this. This is nothing but 3 cube, this is 2 into 7, 7, this is 2 into 3. 7 into 7, 7 square and square root, square will cancel out. 2 into 2, 2 square and square root, 2 will cancel out. 3 power 4 square root, 3 square will come out. So it's 14 into 9, which is 126. Area we get it as 126. Right. Area is known. Now can we also write area as half base into height? Base is how much? BC. Into height is unknown, H. So 21 will go 6 times. So that implies height of the triangle is 12. So that means we got two important details about this triangle. One is area of the triangle is 126. Second, height of the triangle, we got it as 12. I will just keep it ready here in whatever way we want to use it. I am cleaning this. Okay, we get the height. Now let us see how the square is being placed here. How is the square placed? It is placed with one side on the side BC, he says. One side of the square on side BC, something like this. So this is the largest area square, let us assume. Okay, square is like this. So let us assume the side of the square is S. So all sides equal, right? It will be S throughout, right? So if this is S, this is also S. This is also S. This is also S. Okay. We have to find this S only. We have to find this S only. So how can we figure this out is, one of the ways in which we can go about doing it is, can we say area of the triangle ABC, the larger triangle. I will just write it in black, I will change the ink. Can I say area of triangle ABC, which we know is 126, is nothing but made up of, if I call these as some points, this is let us say PQRS. Can I say this area of triangle APQ? plus area of triangle BPS plus area of triangle QRC plus area of the square. We may write it like this. Now let us see what is area of APQ. Area of APQ will be half into base is S, into height. How much will be height? Height of this triangle will be nothing but height of the original triangle 12 minus this side length S, isn't it? Overall height we got it as 12. Out of that we have to subtract this side length S of the square. So can I say the height will be 12 minus S plus BPS. So area of triangle BPS, this is B. So how do we get BPS? Okay, look at BPS and QRC together. Look at these two triangles together. Imagine if I just try to put these two triangles together, they would appear like this, right? This is BPS and this will be QRC. So that means see, this height is same, this is S only, this is S only, right? This height is same, right? That means can I say area of this particular triangle can be taken as, overall if you look at the base now, this BS plus RC, can we say it's nothing but 21 minus S? Do you see this? Overall 21 minus this S. So these two triangles together can I say is nothing but half into base into height S plus area of the square. Area of the square is simply S square. So what is this going to be equal to? Half base into height, which we know is 126, which we know is 126. This will be equal to what? Now when you simplify this, this is going to be 6S, half of 12 6 into S minus S square by 2 plus 21 by 2 into S minus S square by 2 plus S square. Now please note, minus S square by 2 minus S square by 2 is minus S square, plus S square will cancel out. And this will be what? This is going to be 33 into S by 2. 33 into S, sorry. This will be equal to what? This is 126 area. And hence can I say, I continue here, S will be nothing but 2 into 126 by 33. When you simplify, 3 will go 42 times, this will go 11 times. So it's nothing but 84 by 11. So thus the numerator part here should be 84. Alright, so this is how we could solve. See, again in geometry, depending on how you are seeing a problem, there could be more than one ways of getting to the answer. This is how, by just comparing the areas, we can get to our answer for the side length S here. Alright, I hope we are clear with this. You can note this down. Okay. So with this, we are done with the session here today, right? So in this session we just covered couple of questions, but which are of a good difficulty level, right? So I would suggest you to revise these questions later on during your preparation, right? And for more such content, please do subscribe to our channel, right? On that note, let me end the session here. Thank you and all the very best.